Hi folks, after a bit of a hiatus, welcome back to the live review. Wanted to get started with some series, and we'll take a look at quite a wide variety of tests along the way. So we're going to begin with the geometric series. And so the geometric series, there's two formats for them, and we'll take a look at them right here up top. So you can write it as a summation n equals 0 to infinity of x to the n. And then in that case, your first coefficient is 1, so you get this equals 1 over 1 minus x whenever the absolute value of x is less than 1. And in the second case, you have a summation from n equals 1 to infinity of a times r to the n minus 1, and that equals a, being, since that's the first term in this case, all over 1 minus r whenever the absolute value of r is less than 1. There's other ways to write this. I mean, we could have written this last one as a summation n equals 0 to infinity of a times r to the n. That's the same thing. This is also equal to a divided by 1 minus r. So you have the same song and dance going on there. I want you just to be aware of that the whole time. So keep that in mind when it comes down to it. Alright, so moving forward here. Let's see what we got. And so we have determined whether the following series converge or diverge. So this isn't even asking for what value it goes to. So all we really need to check for is what is the actual value. Are we dealing with x? Are we dealing with r? What does this thing look like? And we can go from there. So taking a look at this first one, we need to do a little bit of rewriting. Notice our n equals 1, so that means we're going to want an n minus first power up in that exponent. So we're not quite there just yet, so we need to do a little bit of work. And the way to do that, notice that we can write this as the summation n equals 1 to infinity of negative 3 to the n minus 1 all over 4 times 4 to the n minus 1. The nice part about sums is you can actually bring that out in front. So you can take that little piece right there, that 1/4, and you can pull that out in front of the sum because it's just multiplying by the same song and dance all the time. So this whole thing equals 1/4 times the summation and equals 1 to infinity of negative 3 to the n minus 1 all over 4 to the n minus 1. And a little bit more algebra, since the exponents are the same, we now can combine them into one fraction and one exponent there. So you get 1/4 summation n equals 1 to infinity of negative 3/4 to the n minus 1 power. Now, I could have left the 1/4 in there. I just find that it's simpler to see it that way. So what this tells us is that a equals 1/4 and r equals negative 3/4, which the absolute value of r, so notice that in that case the absolute value of r is less than 1. So this thing, what that tells us is this converges. Now, you'd be dumb right there. Converges since a geometric series. But if we actually wanted to find the value, just a little side note, I'm not saying this is necessary whatsoever, but this is a sum n equals 1 to infinity of, so we had the negative 3 to the n minus 1 all over 4 to the n. That whole thing ends up equaling, well, our a is 1/4, so we plug that in up top, so you get 1/4, and then our r value is negative 3/4, so we get 1 minus negative 3/4. So notice that's the same thing as 1 plus 3/4, and we can write this as 1 over 4 times the quantity 1 plus 3/4. Well, if we distribute that 4 on through, you get 1 over 4 plus 3, or just 1/7 as a final answer as well. So technically you had two parts. You didn't have to do the second part, but I just wanted you to see how we actually work this thing out. Okay, I find that very beneficial when it all comes down to it. Okay, so let's see here. Maybe I can, is it possible for me to scroll this up? So for our next one, let's see here. We're going to try and I'll erase this real quick and hopefully we can fit that in here. I noticed on the screen we're having some technical difficulties on fitting all this material. So let me do a real quick erase and I'll try and adjust accordingly. And I'll try and make sure everything from here on out fits in the screen. So we have a summation n equals 1 to infinity of 2 to the 2n minus 1 all over 3 to the n. Okay. So now with this one, let's see what happens. Well, we got to move it into some format that we've already recognized, and so that'll be our first step. And if that's the case, we can try and work with that. We want to get n minus 1 power, but notice we have a 2n minus 1 power, so we'll deal with that in just a second. So we get the sum n equals 1 to infinity. And we can write the denominator as 3 times 3 to the n minus 1 in the same manner that we did before. Now on top of that, what we have is we have 2, and then we can write this as a 2 to the n, and then times 2 to the negative 1. So what does that do for us? Well, another thing that we can do from there is we can rewrite this as a summation n equals 1 to infinity of, well, this would now become 2 squared raised to the n times 2 to the negative 1, and then we have that 3 to the n minus 1, which is already in position, and we can pull that 1/3 out in front. So moving forward from here, what does that make? Well, this is 1/3 times the summation n equals 1 to infinity of 4 to the n, and then you have 2 to the negative 1, and then a 3 to the n minus 1. So notice that allows us to go, and we can bring that 2 to the negative 1 out in front. That's 1/2, so we can make it 1/6, and then we can keep on going. We have a summation n equals 1 to infinity, and then we have, what else? 4 to the n becomes 4 times 4 to the n minus 1 all over 3 to the n minus 1. We can pull the 4 out in front, so now we have 4/6 or 2/3, and then we have a summation n equals 1 to infinity of 4/3 to the n minus 1. Okay, so notice in this case all we needed to know is that r equals 4/3, which is greater than 1, so diverges. Okay, so hopefully that makes sense on the geometric series. Now I'm actually going to pause here real quick and we'll come back to another video. I'm just going to adjust the screen to make sure it fits with this new OBS.